All right, so this is the ionic bonding quest. First thing is naming ions. So to write an ion, you write the symbol of the atom and put the charge in the upper right corner. So consider the following examples: Al with 3 positive, O2 negative, Mg2 positive. You should verify each of the charges is correct. And all I do is look at the periodic table. Aluminum's here, which is the 3A, which is the positive 3 charge. Oxygen is here, 6A, which is negative 2 charge. And then we have Mg, which is here, which is in the positive 2 charge. So let's review that. All right, so this first group right here, all here, positive 1. All of these are positive 2. Transition metals vary. Aluminum is positive 3, and some of these have positive 3 charges. No charge here, okay, or positive 4 or negative 4, depending on the situation, but mostly no charge. On this side, the 5A, nitrogen, phosphorus, and arsenic, always negative 3. These two down here will have some positive charge to them. Oxygen, sulfur, selenium, always negative 2. And all the halogens are negative 1. And of course, the noble gases have no charge. All right, so that's the review for that we talked about before. All right, so positive and negative ions are named differently. Positive ions are just the name. So Al3 positive is just the aluminum ion. And Mg2 positive is just the magnesium ion. Negative ions have "ide" at the end. So O2 negative is the oxide ion, and P3 negative is the phosphide ion. So that's just a slight difference. But let's see if we can get the symbol and charge for each of the following ions. So calcium is right here. All right, calcium on the periodic table is in this group 2A, which means it has a 2 positive ion. So symbol and charge, Ca, 2 positive. Make sure you put the 2 positive in the upper right-hand corner. Chlorine is a halogen, so it's right here, which makes it a negative 1 charge. So chlorine, Cl, is just a negative charge. Remember, 1's always implied. Nitrogen is here, group 5A. Those are negative 3 charge, just like the phosphorus was, the phosphide ion. So it's N, 3 negative. Potassium, K. K is right here. It's in the first group, so it has a positive 1 charge. So it goes K positive. Sulfur, when we look over here, is right here. It's group 6, right below oxygen, so it'll be the same as oxide. So the sulfide ion is S2 negative. Boron, and we find that right above aluminum, so it'll behave like aluminum. It's group 3A, which means it has a positive 3 charge. So boron, 3 positive. And then phosphorus is here, P, and it's right below nitrogen, and it will have a negative 3 charge. So the phosphorus, 3 negative. Now remember, those are the charges aren't in bold print; they're a superscript up and to the right of the atom in charge. I just can't type it that way using this software. Okay, so that's how the charges go. There are 2 ways in which atoms can bond to each other to form a compound. The means of binding that we will consider now is called ionic, which occurs between a metal and nonmetal. And as you know, opposite charges attract. Ionic bonding is when 2 ions of opposite charge attract to form to each other, forming an ionic compound. Consider the following examples of formulas for ionic compound: 1 positive sodium, 1 negative chloride, make NaCl, which is sodium chloride. 1 magnesium ion and 2 fluoride ions bond to make MgF2, which is magnesium fluoride. 3 calcium ions and 2 nitride ions bond to make Ca3N2, which is calcium nitride. 1 aluminum ion and 1 nitride ion bond to make Aln, which is aluminum nitride. So the small numbers to the bottom right of the formula are called subscripts. Subscripts tell us exactly how many of each type of atom are present. For example, in the formula Mg3N2, there are 3 magnesium ions and 2 nitride ions. All right. So consider the formula NaCl above. It tells us that 1 Na positive is bonded to 1 Cl negative ion. What is the overall charge of NaCl? Is it positive, negative, or neutral? Well, if you have 1 positive and 1 negative, they balance up. So it'll be neutral. Consider MgF2. We have 1, 2 positive, and 2 negative F negative ions. What is the overall charge? So if we have 2 negative 1s and a positive 2, that's negative 2 and positive 2. Again, that is a neutral charge. So what is overall charge in any ionic compound? And it will be neutral. And if we can remember that, we can get things to work then, right? So why is calcium nitride written like Ca3N2 and not like CaN2 or Ca2N3? In other words, why do exactly 3 calcium ions bond with exactly 2 nitride ions? Well, if you look, calcium is +2 and nitride's -3. So if I think about it, if I have Ca2 positive, right, and then over here I have N3 negative, my charges aren't balanced. So I'm going to add another Ca2 positive. So now I have +4 to -3, so I need more negative charges. So I go N3 negative. Now I have -6, +4, and I add another positive to try to balance it out. And in the end, I have +2, +2, +2, which is +6, -3, -3, -6. Now it's neutral. I used 3 Cas and 2 Ns. 3 Cas, 2 Ns, and that's where the formula comes from. So we can never write it as N2Ca3. So to find out why, take note of each of the 4 examples of the formulas given above. In terms of charge, what do the first ions named all have in common? So let's look. Boom, 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 boom. Well, they're all positive ions. So they are positive ions. What do the second ions all have in common? They are all negative ions. So why can't Ca2 be written as N2Ca3? Because Ca is positive ion, and that goes first. So the 2 rules of writing formulas for ionic compounds. One has to do with charges, and the other has to do with which one to write first. So what are the 2 rules? Well, rule 1, right? Ionic compounds are neutral, which means positive and negative charges are equal. That should be a Q. Are equal. Right, so that's rule 1. Rule 2 is positive charge ion, positive charged ion is always listed first in the name, okay? And if we follow those 2 rules, we can make any ionic compound. So let's look at number 8. What is wrong with the following formulas? Al2S. Well, let's take a look at this. So Al, if you look at Al's here, it has this one here, so it's 3A, so it's a +3 charge. So Al is 3 positive. And sulfur is here, it's under oxygen at 6A, which is -2 charged. So sulfur is 2 negative. So if I have 2 Als and 1 sulfur, I would have +6 and a -2. Well, what's wrong with this one? Well, it's easy. Charges don't balance. That's why this one's no good. So let's look at PNA3. So same process. P is, and we'll find phosphorus, is right here. It's under nitrogen, group 5A, which is -3 charge. And sodium, when we look here, is this first group, so it's +1 charge. We have 3 sodiums, which gives us 3 positive charges. So I'm going to type this 3 times. Positive, positive, positive. So +3, -3. So charge is balanced. But phosphorus is listed first. Okay? So it's wrong because negative ion is first. All right? Positive ion is first. So the formula for this should be Na3P, not PNA3. Now, Mg2S2. And this one's kind of tricky. Mg is a +2 charge. All right? And I have 2 of them. So I go Mg, 2 positive, and I go Mg, 2 positive. And then sulfur, when I find that in the periodic table, is right here under the O. It's -2. So it goes S2 negative and S2 negative. So my charge is balanced. Positive 2 is positive 4, negative 2 is negative 4. So those balance. Mg is listed first, and it's a positive ion, so it's listed first. So what is wrong with this? Well, if I look, if I have 2 and 2, it's the same as 1 and 1. So one other rule I want to add to this list, okay? It should be MGS, all right? Because we want how to word this for you, because we want smallest whole number ratio in an ionic compound. That's a formula unit, okay? So it's there because we want the smallest whole number ratio. So if I have a positive 2 and negative 2, I just need one of each. I don't need to put 2 of each. Even though it does work, I want to put one of each, okay? So on your own, do 9 and 10 and pause and do that, and then I will show up on the board and show you how to do those. Good luck. All right, so here's the end of the assignment. I wanted to do it on the board so that you could see where I'm getting my answers from and my numbers from. So nitrogen and sodium. Looking at my periodic table, I know nitrogen has a -3 charge and sodium has a positive charge. I need to get 3 total positive charges to balance that out. 3 positive, 3 negative. Now it's balanced. Once I have my balanced charge, now I just got to put the positive charge first, and I use 3 NAs, so it's Na3 and 1 N, Na3N. Okay, barium and sulfur. Barium is group 2A, it's an alkaline earth metal, it's positive 2. Sulfur is right below oxygen, that's a -2. My charges are balanced, so my formula is just going to be BAS. Magnesium and iodine. Mg, 2 positive. Iodine is a halogen, it's -1. I have to balance by putting more negatives in, so I added a negative here. 1 of these, 2 of these, put the positive charge first, Mgi, 2. Oxygen and aluminum. Oxygen, -2, aluminum, positive 3 charge. This one I have to go back and forth a little bit. So I added 2 more negatives, and then I add 3 more positives, and then I add 2 more negatives. -6, positive 6. Put my positive charge first. There's 2 of those, and then there's 3 O's. Al2O3. All right, calcium and phosphide. Calcium is positive 2. Phosphorus is -3. Same idea. I have to go back and forth, so I add a positive 2. And then I add a -3, and then I add a positive 2. Positive 6, -6. Ca3P2. Sodium and sulfur. Sodium, positive. Sulfide, -2. I need to have more positives. 2 positives, 2 negatives, 2 NAs, 1 S, Na2S. For the names, and you should write the names out. I'm not going to write them out for lack of board space, but this is sodium nitride. Okay, I guess I'll write the last names out because you can see how to spell them. Nitride. Barium and sulfur would be barium sulfide. Magnesium and iodine would be magnesium iodide, I-O-D-I-D-E. Aluminum oxide, O-X-I-D-E. Calcium phosphide. And this is sodium sulfide. Okay, so now for the bottom ones. So if we want to determine the charge on this, right? I know sulfur is -2. And there's 1 of them. There's 2 X's. Oh, lights went out. So knowing that, what do my charge on my X's have to be? Well, they have to total 2, but there's 2 of them. So each X has a positive 1 charge. Mg and X. Mg is a positive 2 charge, and there's just 1 of them, and there's just 1 X. So to balance my charges, I need a -1, -2 charge. Okay, so we got X and P. P's -3, but there's 2 of them, so -6 charge, and there's 3 X's. So to get the +6, each of these has to be +2. So my X has a +2 charge. And that's how you solve those. This is kind of extra, but you should be able to do this. You have to be able to do that.